Hello everyone. I did my lashes. What do we think? I like them. Um, I want to get on here and do like two. I haven't edited my last video yet. You'll see that soon. Maybe this video might come out before my big video, even though that one was filmed first. We'll see. I haven't had the time to upload them yet. But I would like to come on here and create two new videos, like the short ones, about conjugates and the fundamental theorem of algebra. So let's get into it. Two separate videos. So today's topic is going to be on conjugates. I'm doing this because I don't really understand what they are that much. I made a notes page because I was watching a Khan Academy on this, and I took some notes while I was watching it. So conjugates are essentially they're a inverse used in complex equations to get imaginary numbers out of the denominator. So in equations where there is a numerator and a denominator, and there is a expression that includes an imaginary number within the denominator, you can multiply just as you can multiply just as when you have a square root in the denominator and you can multiply it by a square root over a square root, like the same thing, because you multiply it by 1. If you know, you know. It's the same thing there, since you have like hold on. I need to like root my thoughts together. So it's like since you have, we're going to give the example of square root equations or expressions. When you have, say, 2 times the square root of 8 divided by the square root of 2, you can multiply that whole fraction by the square root of 2 over the square root of 2 to get rid of the radical in the denominator. It's the same concept here with imaginary numbers. So you can multiply the imaginary number, or the expression containing an imaginary number. You can multiply the denominator by the same expression, but you're trying to get rid of the imaginary number. So you're trying to make it a real number. So you'll multiply. I'll write it out. I give up. So if you have your expression 2i divided by 5 plus 3i, what you will do is you multiply the denominator by 5 minus 3i. Right? So you multiply both the numerator and the denominator, because you have to multiply the whole thing by 1, because you're not changing the equation, you're not changing the expression then. So I don't really know why it has to be the opposite sign, but when you do this, you'll multiply them out. So down here you have two binomial, or actually, no, you could just multiply like terms together. And so you'll get in the denominator, so if you're multiplying 3i times negative 3i, 3i times 3i is 9i squared, and I squared is negative 1. So you have negative 9. So you actually add 9 to... Oh, so the purpose of changing the sign of the imaginary number makes it so the denominator will be positive, so you don't have to worry about having a denominator that's negative. It's just more work later on. So that helps you, because I think you can multiply it by just 5 plus 3i. It would just, you would have a negative number in the denominator, and you want to get rid of that later. But so then you have to multiply the top too. Multiply the top numbers, because you can't just do the denominator. That doesn't work like that. So you have 10i so far, because you multiply 2i times 5 minus 3i. So you have to multiply 2i times 3i. So that equals 6i squared, but I squared is negative 1. And then so you have 5 plus 6. 10i plus 6. So then we'll just simplify each of the things in the equation. So you have 10i plus 6 over 36. No, 34 over 34. I was like, did I do that perfectly? What? 10i plus 6 over 34. Does that? I think it's divisible or something. So you can divide everything in this expression by 2. So you have 5I plus 3 over 17. Cool. This, but you can't, sorry. So this would be your answer, but hold on. You have to, since 5I and 3 and like the real numbers and the imaginary numbers are not the same thing, you have to separate it. So it'd be, right? It'd be 3 over 17 plus 5 over 17I. So I'm pretty sure that is the correct format to write it in. So yeah, that was just conjugates. So all it is, you're just trying to get an imaginary number out of the denominator and also make the denominator positive, is all it is.